Hello, everyone. Welcome back to Python Challenge for All. One more fun about um, bitwise operators. So last time we find an interesting way. We used a interesting way to swap two variables, uh, which contains two different integers, okay, without using a third temporary variable t. Of course, yeah, usually we do t equal x, x equal y, and x equal t, that kind of thing. But using this exclusive operator, exclusive OR operator, I show that we can do it in three operations without any third temporary variable. The trick is that, yeah, like this, the characteristics of exclusive OR in Python is hat operator. And also they are, yeah, it is commutative and associative. Today we'll see, let's see, this part is a bit confusing. So I rewrote a bit. So here, x, y are for variables and x0, y0 for values. So here, after x hat equal y, we have x equals x0 hat y0, okay? After the second uh, statement, y hat equals x, now it is computed like this, and using commutative and associative property, what we get is now y contains x0, the original x value. And the third statement, x hat equal y, will calculate this, x equals x hat y, which is now x0 hat y0, which is this one, hat x0. And after using commutative property and associative property, we easily find that this is equal to this. And since from this property, we see this is 0, and since from this property, we knew that this is y0, the original y value, is now assigned to x. And original x value is now assigned to y. That's what we checked with the code. Okay, what is today's topic? So today's topic is about playing with bits again. Who's the loner? Oh, what do you mean by that? So the problem is in an integer list where every number appears exactly twice except one element. So it's like this. Okay, we want to find a single loner, this one. Okay, it's like this. Given a list of integers, odd number of integers, which contains, okay, a pair of 31, a pair of, say, 54, and pair of 2's. Okay, so here the loner is, as you can see, 23. So using from this list, we want to find 23. And interestingly, again, bit operator exclusive OR can do a trick about this. So again, yeah, remember that there are interesting properties like, yeah, like this one. Yeah, means x hat x equals 0 and x hat 0 equals always x. And also they're commutative and associative. Okay, so actually, the exclusive OR of all elements equals the loner. Ah, interesting. Let's see, take a look. How can we do that? How can we implement and check if it is true? Okay, let's try with this list. 0, 32. Okay, let's write this way. Okay, so let's see, have a list of, let's do it the same way. 2, 31, 23. 2, 31, 23. And what are the others? 54, 31, 2. 54, 31, 2. And lastly, 54. Okay, so now we know what the answer is. But anyway, what we want to do is, let's um, let's define an answer, which is 0 initially, and do the loop for element in L. Okay, do ans hat equals E. Okay, as you see, this means ans is equal to ans hat E, meaning take the exclusive OR of ans and E. And that's all, actually. Okay, after doing this, let's print out, or let's print out. Shall we print out after each element? Maybe not. Okay, let's print out the last element after doing all this for all elements of, say, 7 elements. Let's see what we have. Good. Now we have the loner here. And that, of course, doesn't matter how many elements there are and what kind of elements. For example, there are -3 here and -3 here. Like that, we can still have the loner. Okay, let's see if change this to 23 instead of -3. Now we have the correct answer, -3 here, because now 23 are in pairs. Okay, interesting. What's the point? Okay, so yeah, please find out the what we have after each element, say ans. Okay, and maybe this might help, and this might not help. Interestingly, by taking the bin of E and bin of ans might help you see what's the trick. But anyway, it works fine. Okay. So do we need, in this implementation, we used loop. But actually, there's one interesting way to do it in one statement, one command. And I'll tell you that using functools.reduce function. So usually we do it from functools import reduce. And then we can see that answer is, okay, actually we don't need print. So answer is reduce, and we define lambda function here. I hope you know lambda function. Lambda function is a anonymous function, or function without temporary function without name. So given 2 parameters x and y, compute x hat y for all the lists in L and the initial value of 0. So let's write it. So lambda x and y colon x hat y. Okay, and next the list of functions, which is L here, up here. Up here we have L. And the initial value of 0, which corresponds to this one. Okay, now computing this will produce 3 again. Okay, interesting, right? So as you can see, if you change this to again -3, of course it has. If we run this and run this, it will give the same answer. So while this has for loop, it has only one statement. Maybe you like this is better, but anyway, it will print 23 answer, and you will think why it works like this. Interesting. So this is a trick to find the loner from a list of mostly paired integers. I hope you enjoyed it. Okay, that's all for today. Please come back next time. Bye-bye.